Hello my dear students, welcome back to Learn Physics. In today's video, we are going to discuss about the ray optics portion, in that numericals from the optical instruments. This is the last part of this ray optics chapter. Okay, so last class we discussed about the important formulas that we should consider in the case of optical instruments. These were the important formulas which we learned in the last video as PPT we learned, right? So today we are going to, so in last video in sound some disturbances were there, I know that, but since it was PPT, everything was written over there, I didn't, let's say, I can't rectify that after putting that video, after uploading the video. I'll try to give another video for the same slides itself. I'll try to give, okay? So this important formula, so simple microscope, magnification, all the magnifications only will be usually will be asking only about the magnification. So m equals 1 plus d by f. In simple microscope we will be using only one lens, okay? Here 1 plus d by fe. And compound microscope, two lenses, near to eye which is coming as eye lens, and near to object which is coming as objective lens. And here formula will be m equals VO by UO into 1 plus d by FE. How we are getting it as mass of magnification of objective into magnification of the eyepiece. So objective VO by UO, eyepiece 1 plus d by FE. Okay, the same way we are getting the formula for the total magnification of compound microscope. And telescope, m equals FO by FE for normal adjustment, and for at least a distance of distinct vision, m is equal to FO by FE into 1 plus FE divided by D. Okay, so these are the important formulas in the case of telescope. And a refracting type telescope or a reflecting type of telescope, m equals FO by FE, R by 2 divided by FE. That is the formula. Okay, so all those formulas we discussed already. Those who didn't watch the previous day's video, please watch that and then come to this topic, that is ray optics. Today's first question, you can write down the question. The focal length of objective and eyepiece of a microscope are 1.25 cm and 5 cm respectively. Find the position of the object relative to the objective in order to obtain an angular magnification of 30 in normal adjustment. So here we are using microscope. Here for microscope, objective and eyepiece are there, therefore it is a compound microscope. So FO is given, FE is given, we need to find out the value of UO. Okay, objective, object, find the position of the object relative to the objective. That means we should find out the value of UO. FO is given, FE is also given. Now, and apart from these values, magnification also given. Magnification as formula is, the magnification is given as 30. Okay, so how can we find out UO? So here the objective, focal length of the objective is given as, objective and eyepiece are 1.25 centimeter and eyepiece it is given as 5 centimeter. Then we should find out the position of object from the objective lens in order to obtain an angular magnification of 30 in normal adjustment. Okay, in normal adjustment means we will be getting the image at the infinity. Okay, image we are obtaining at infinity. So here, how can we find out this UO? We know formula 1 by F is equal to 1 by U plus 1 by V. For that V also we don't know. So first we will try to find out V. Okay, to find out 1 by F equals 1 by V minus 1 by U for the lens formula. In that we have FO, VO and UO we don't have. So we are trying to find out the value of V. For that magnification is given. Magnification M equals MO into ME. Right, but we don't have the value of MO and ME separately, but it is given under normal adjustment. At normal adjustment, what will be the magnification of the eyepiece? Magnification of the eyepiece will be equal to D by FE. D we know it is 25 centimeter. FE is given as 5. So what will be the value of ME? That is 5. So M equals 30 equals MO into 5. So what is MO? MO we will get it as 6. Here we are getting the real image will be formed by the objective, right? Objective lens will be forming a real image. So that real, since it is a real image, MO we can consider it as 6 minus 6. So here I am taking it as minus 6 since the image is real. So MO equals VO by UO. Like that one formula is there. That is equal to minus 6. So we will get VO as minus 6 UO. Substituting the values over here. 1 by FO, 1 by 1.25 equals 1 by minus 6 UO minus 1 by UO. So we can take minus 1 by UO outside. 1 by 6 plus 1, that is 7 by 6 we will get. The rest of the things 1 by 1.25, that is equal to 7 by 6 UO minus. So UO equals 7 into 1.25 divided by 6. Like that you can find out the formula. We will be getting the answer in negative. The final equation after calculation you will get it as minus 1.46 centimeter. Okay, so this is minus 1.46 centimeter. That through calculation you can find out. Clear? So the next question is, a compound microscope has an objective of focal length 1 centimeter. Objective focal length 1 centimeter and an eyepiece of focal length 2.5 centimeter. An object has to be placed at a distance of 1.2 centimeter away from the objective. Okay, so UO, that is negative. Okay, 2.5 centimeter, 1.2 centimeter away from the objective for normal adjustment. Okay, so image will be forming at infinity. For normal normal adjustment means image will be forming at infinity. Find the angular magnification and the length of the microscope used. Magnification we should find out, and length of the microscope will be equal to U plus FE. Right, FO plus FE, that will be the length of the microscope. Okay, we'll do that. So while I'm reading out the question, you can please write down the question and then try to solve by yourself. Then you can, if you have any doubt, you can just find out the answer. Okay, so if you want, I'll tell the answer now itself, and then you can pause the video and find out the answer. You should get it as M value, you should get it as 55, and length you should get it as 8.5 centimeter. So those who want to try, they can try that and just check after that whether it is correct or not. Okay, so here in the question it is given, a microscope has an objective focal length of 1 centimeter. So FO is equal to 1 centimeter. Eyepiece FE equals 2.5 centimeter. An object has to be placed at a distance of 1.2 centimeter away from the objective for normal adjustment. For normal adjustment, what is the formula for that? VO divided by UO into 1 plus D by FE. This is the formula for normal adjustment. So 1 centimeter, objective is kept at a distance of 1.2 centimeter. Okay, and we have to find the angular magnification. M we need to find out, and length of the microscope also we should find out. How can we find out this? See, magnification. What is the formula for magnification? M equals VO by UO into 1 plus D by FE. For that we don't, D is 25 centimeter, and here FE we have, VO we don't have, UO we don't have. So we can first find out the value of VO. FO is given, UO is given. So 1 by FO equals 1 by VO minus 1 by UO. Therefore, here we can write it as, otherwise I'll do like this, 1 by UO equals VO. VO we need to find out, right? So VO, 1 by VO equals 1 by FO plus 1 by UO. Therefore 1 by 1 plus 1 by 1.2. Now it will become minus. So 10 by 12 we will get. Here 12 by 12 minus 10 means 2 by 12. So we are getting it as 1 by 6. Therefore VO we get it as 6 centimeter. So we can substitute over here. M equals 6 divided by 1.2 into 1 plus 25 divided by 2.5. So here it is, you will get it as 60 by 12. So 10 by 2, 5. 5 into 1 plus 10. 11. 11 5s are 55. This is how you will find out the magnification. Now we need to find out the length. So if we have a object like this is the objective, and eyepiece will be little bit bigger than the objective. Okay, so here the image will be forming at the infinite, at this point. Here this will be the focal length of the eyepiece, and here this will be the image formation, that is U, VO. VO plus UO will give you the eyepiece focal, the length of the tube. Length of the tube will be at normal adjustment. This image position will be, the image of the objective will be the position of the focal length. At the principal focus of this lens, eyepiece will be, the image will be formed. The image from objective will be formed at the principal focus of the eyepiece. Therefore, UO plus FE it will be. So, what is L? L will be equal to UO is VO. VO is 6. We are getting C 6 plus FE is 2.5. Therefore, 8.5 centimeter. Clear? This is how we will find out this. So, this kind of if we know the formulas, it will be easy for this kind of questions. Clear? So, next is from your exemplar questions, that is additional exercise question. One question I will ask. An angular magnification of 30 is desired using an objective of focal length 1.25 centimeter and an eyepiece of focal length 5 centimeter. How will you set up the compound microscope? How will you set up the compound microscope means at which position we should keep the object distance, image distance, all those things you should find out, and for what adjustment we should make it for our eyepiece. Okay, that also you should find out. Here the question is, the angular magnification is given as 30. So magnification, total magnification is 30, and objective, by using an objective of focal length FO 1.25 centimeter and FE 5 centimeter. Here we should find out the position of UO and VE. What is the initial position of the objective? Inside that what and all happening we don't know. So we are keeping the adjustment from the object, from the position of the object to the first lens. That adjustment we are making. And here using the knob we will be adjusting the position of the eye to the lens. That also. So we will be finding out the value of VE and UO. VE and UO we need to find out. So what adjustment we should make to get the clear image? That is the question, right? So here we are going to find out the value of UO and VE. These values are given. How can we find out? First our aim is to find out the magnification. M is equal to MO into ME. Okay. So here how can we find out the either MO or ME? We find out ME, we know it is ME equals 1 plus D by FE. This is the formula for finding out ME, right? Here total magnification is M. So here 1 plus D is 25, FE is 5. So here we will get it as 6. So if ME is 6, what will be MO? MO will be 5. 30 divided by 6, that is 5. So here FO value also we have. Now we can find out the value of 1 plus 1 by V minus 1 by U equals 1 by F. MO equals VO by UO. Last one question we did, right? Same way. Phi divide equals VO divided by UO. Therefore, VO equals 5 UO, or UO only we need to find out, right? So, 5 UO, substituting in this. Here, 1 by 5 UO minus 1 by UO, that is equal to 1 by 1.25. So, here 1 by UO into 1 by 5 minus 1 equals 1 by 1.25. Oh, here also we forgot to take the real image. So it is minus 5 UO. Here also minus. So minus we can take it outside. 6 by 5 we will get. 6 by 1 by 1.25. So here we can write it as 1 by UO equals 1 by 1.25 into 5 by 6, because we will get here as 6 by 5. So 5 by 6. So UO equals 1.25 into 6 divided by 5. That is minus, negative value. So when you are finding out the answer, you will get it as minus 1.5 centimeter as UO. Now we are getting this as 1.5 centimeter. Okay. Now our aim is to find out VE. How can we find out VE? VE equals 1 by F equals 1 by VE minus 1 by UE. Same way we have ME value with us, right? Same way you can find out VE. While finding out VE, it is 7.5 centimeter you will get. 7.5 centimeter. So I think from this you can easily find out the rest of the things. The formulas and all, it's clear for you, right? So I think from this you would have got an idea about the such kind of questions, and if any other doubts are there, you can just say it in the comment box. In the next revision class we will be solving that and all. And in next class, if no other doubts, no other comments from relating to this video, I'll be moving to the next chapter, that is wave optics. There also we will be discussing only the theory portion and the numericals and all. Derivations, we are not going deep into derivations. That is Young's double slit experiment, wave, what is meant by wave theory, Huygens wave theory, and Young's double slit experiments. No derivation, nothing. Derivation already did in the previous year. So it is there in the playlist. You can just go through that if you want, and otherwise listen to the theory portion. Okay children. So I think this will be useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.